All right, students, welcome to your very first preview video. We're going to be talking about the algebra review, radicals and lines. Hopefully some of this stuff you've seen before. We're going to go over it as if it's been a while, so stay right with me. So in order for you to get credit for this, you must first tell me where you are watching this video as well as the date and time. And then either a parent, guardian, a teacher, or librarian sign off that you're watching these videos in person. Keep that in mind. Take a look at this page. This is review. What I'd like you to do is I'm going to set the timer for 3 minutes. In 3 minutes, I'd like you to do the absolute best that you can do to solve for x. If you finish in under 3 minutes, go ahead and fast forward the video until you see the 3 minutes expire, and then I will go over the solutions with you. But do the best you can on your own. 3 minutes starts now. All right, let's see how you did. Step 1 here, of course, is that you should have taken this distributive property right here. So double negative, that's going to be positive 5 minus x. Let's bring over everything else. We have 2x minus 1 equals x minus 3. And that's going to be plus 5 minus x. Now we're going to collect like terms. On the left side, there's only the 2x. And on the right side, there's a negative x and a positive x, so they cancel. So now we collect the non-x terms. That's minus 2. And that's positive 2. So we add 2 to both sides. 2x equals 4, and x in this case equals 2. If you take the value of x and plug in it up here, it will balance the equation. Okay, taking a look here, don't be intimidated by fractions. The first rule of fractions is get rid of them if you can. The way we're going to get rid of them is we're going to multiply everything by the lowest common denominator of 3 and 5. The lowest common denominator of 3 and 5 is just when you multiply them, so our LCD is 15. So we take a 15 and we're going to put it on the outside. Now we do this one step at a time. You take the 3, that's in the denominator. 3 goes into 15 5 times. We bring that 5 around the top, we get 5x. Plus, circle the 5. 5 goes into 15 3 times. I'm going to bring the 3 around this way. Now this is where it gets tricky because you have to multiply both terms. So we have 3x minus 6. And the last one, technically there's a 1 down here. 1 goes in there 15 times, so we have 15 times 6. So that equals 90. Now we've said goodbye to the fractions. Now we collect like terms. We have 8x minus 6 equals 90. Add 6 both sides. We're going to divide everything by 8. 8 goes into 9 one time, 1 left over, that's 12. So x equals 12. Double check your work. Your answer should have been 2 and 12. If it's not, you should pause this video and try to figure out how to get the correct answer here. Okay, today we're going to talk about lines and radicals, so two distinct subjects. I'm going to read the vocabulary words. I'd like you to check them off as I read them. By the end of today's lesson, you're going to be more familiar with the x and y axis, the concept of slope, no slope, and zero slope. Be very careful. These are not the same thing. That's a not equal sign. The slope-intercept equation of a line, point-slope equation of a line, the standard equation of a line, horizontal and vertical lines, what are their equations, radicals, and simplifying. Now, equations of lines, they look like simple equations, but they actually influence the equations of things like predictions in the stock market. You can use equations of lines to project future items because they are close to lines. We'll be talking about the practical applications in class, but first let's recap the simple stuff. The simple stuff includes definition of slope. The definition of the slope is the rise of a line over the run of a line. The rise of a line would be how much it goes up and down, and then the run of the line is how much it goes left or right or horizontally. That together, rise over 1, would constitute the slope. Rise over run. When you look at a graph from left to right, if it's going upward from left to right, it's a positive slope. If it goes downward from left to right, it's a negative slope. So you read graphs from left to right. So reading a graph from left, going towards the right, if you were to see a line that looks like this, its slope would be a positive slope, which means it would have to be a positive number over a positive number. That is a positive slope line. A negative slope line would be any line that slopes downward. That's a negative slope line. To get a negative slope, you can have a negative over a positive or a positive over a negative. Both of those would give a negative slope. Now, zero slope and no slope, be very careful with these. These are not interchangeable. A zero slope is when you have a 0 in the rise. You have no rise. 0 over the rise, over any other number. If you have no rise, that means the line is completely horizontal. It has no up and down. So a 0 over any number is just 0. So all horizontal lines have 0 slope because they have no rise. Now, no slope goes like this. It means you have no run, so technically there is a 0 in the denominator here. So there's a number over 0. We have a saying in the math department, only God can divide by 0. The rest of us, we can't do that. So we would call this no slope or undefined. And since it has a 0 run, that means it has no left or right motion. So technically, a no slope is a vertical line. A no slope is a vertical line. You also know that as undefined. Take a moment and make sure you have an example of each of these on your graph. We're going to start with the most common equation of a line, the slope-intercept equation of a line. This is the one you're probably familiar with. The slope-intercept equation of a line is y equals mx plus b. Now, definitions. This b here is the y-intercept, and of course the m is the slope. So when you're working with this equation, what I recommend you do, whatever equation you start with, always simply rewrite the equation directly underneath it. Line it up. So here we have y equals negative 2/5 x minus 5. So I'm going to write y equals mx plus b. I'd like you to circle the b and the negative 5, please. Now the y-intercept, therefore, is negative 5. That's your b. I'd like you to circle the m and what it corresponds with, which is negative 2/5. Now we can write it negative 2 over 5, or we can write it like this. 2 over negative 5. I'm going to show you in a moment that it really doesn't matter which way you write it. Don't be intimidated by that negative sign. Very first thing I'd like you to do is establish if this is a negative or a positive slope. And we can see we have a negative slope because negative or positive is negative, positive over negative is negative. So just draw a quick little sketch. You have to tell yourself, I know the line's going to tilt downward here. However you count it out, the line must tilt downward. Now we're going to start by graphing this intercept, and it's along the y-axis. So I'd like you to trace the y-axis. Now put a dot at negative 5. I'm going to count both of these. Negative 2 over 5 looks like this. We drop 2, and we go over 5 to the right. That would be negative 2 over positive 5. Now the other one, positive 2 over negative 5, would look like this. Positive 2, we go up 2. And negative 5 means we go to the left. See, we have 2 points here. If you look carefully, when you go to graph this line, it's actually the exact same line. So it doesn't really matter whether you count down and over or up and over. What does matter is that this is a negative line, so it must tilt downward from left to right. It's a negative line. What I'd like you to do is hit the pause button, please, on the video, and I'd like you to try to do this problem completely on your own. Then restart the video, and we'll go over it together. Please hit pause and try this on your own. Do not copy. Do it on your own, then restart the video. Okay, welcome back. The first thing you should have done if you're following my directions is you should have written y equals mx plus b directly under y equals mx plus b. Now we establish the intercept, which is positive 4, and then our slope here is 3. However, because it's a whole number, we're going to put it over 1. So we have 3 over 1. And notice it's a positive slope, so you should do a quick little sketch. No matter how you count this out, your line should tilt upward from left to right. So to start, it's the y-intercept along the y-axis. So we're going to trace the y-axis. And now we're going to go to positive 4. That is that. And now we're going to count out rise over run. 3 over 1. So I'm going to go this way. I'm going to drop 3, 1, 2, 3, and go over 1. Or I could go up 3, 1, 2, 3, and I can go over 1 to the right. But notice I'm choosing my directions. I ultimately want my line to tilt upwards from left to right. So your line should look like this. The most common mistakes, I'm going to show you in bright green. The most common mistake, the first common mistake is that students start on the x-axis instead of the y. Second common mistake is you don't count out slope properly, that it's positive or negative. Double check your work. If you made a mistake, try to figure out what you did. This is called slope-intercept equation of a line. Now the second method is called the standard equation of a line. This basically looks like this. You're going to have something x plus or minus something y equals something. I prefer to use the boxes. Some students get confused if you toss too many letters at them, but this, in a textbook, this is what you're going to see. ax plus by equals c. That's called the standard form equation of a line. Now there's 2 ways to tackle this. I'm going to show you how to do this both ways. You are welcome to use either method in this class, whatever makes you most comfortable. The first thing you want to do is rewrite the equation right underneath. So we have ax plus by equals c. Now, slope-intercept form is y equals mx plus b. I'd like you to copy that down. Now circle the y. To get into y-intercept form, you want to isolate the y. Isolate the y. So let's take this example here. 3x plus 4y equals 12. Now I'd like you to circle the y. Your goal is to get y completely by itself. So the first thing you want to get rid of is not the 4, you want to get rid of the 3x. We're going to minus 3x both sides. Next line should read 4y equals, I'm going to bring the x forward because In y equals mx plus b, that's the first thing you see. So I have negative 3x plus 12. Again, your goal is to get y all by itself, so I'm going to divide everything by 4. I get y equals negative 3/4 x plus 3. And then you graph it. Now that's called changing to y equals mx plus b. There's a second method. This is the method that's actually preferred in Algebra 2, just to give you a heads up. I will let you use both, but in Algebra 2, this method is preferred. First, I'd like you to go ahead and rewrite the equation here. Now you're going to draw 2 sets of parentheses. These are called the intercepts. We're going to go 0 in the x, comma, blank for the y, and then flip it around, blank for the x and 0 for the y. These are called the x and y intercepts. Okay, now just use a little brain power here. If we put an x in the 0, come over here, that basically scratches out the x. If we put a 0 there, that's 3 times 0. Now we have 4y equals 12, so y, if you divide by 4, of course, equals 3. So our first intercept is 0, 3. Let's do the other one, the other intercept. This is where y is 0, so you come over here, you can cover it with your finger. I'm just going to scratch it out here. That would make that y disappear. So I end up with 3x equals 12. And if you were to divide, that would mean x equals 4. Okay, so let's try graphing these. Let's do this both ways. Y equals mx plus b. Our b here is positive 3. So we come up, positive 3. Notice it's a negative line. So we want our line to go down from left to right. So we rise 3 and we run 4, and we want a negative line. So I can drop 3, 1, 2, 3, and I could run 4, 1, 2, 3, 4, or I could rise 3 this way, 1, 2, 3, and run to the left, 1, 2, 3, 4. Okay, that's graphing by y equals mx plus b. Or if you just graph the 2 intercepts, that would look like this, 0, 3, 0, 3, that's this point right here. That's called the y-intercept. And 4, 0 is right here. That's called the x-intercept. And as you can see, those 2 points are directly on the line. So you could graph those 2 points and string a line, or graph y equals mx plus b. What I'd like you to do is use that example, and I'd like you to attempt to graph that line right there. Either isolate the y and use y equals mx plus b, or use intercepts. Use whatever makes you comfortable. Hit the pause button, graph, then check your work. Okay, for this one, I'm going to go ahead and just start with the intercepts. So I like to go 0, blank, and then blank, comma, 0. I call that the winkies, because it looks like eyeballs winking to me. Whatever it looks like to you, if you want to make some sort of association to help you remember it, that's how I do intercepts. So I put a 0 in the x. That means the x goes by. I have negative 2y equals 18. If I divide by negative 2 there, I get negative 9 for the y coordinate. If I come over here and I do the other, and I put a 0 in the y, I go like this. 6x equals 18. That means x must equal positive 3. If you did y equals mx plus b, your final line should look like this. Y equals positive 1/3 x minus 9. Now, let's go ahead and graph the two intercepts. Your first intercept is 0, -9. That's down here. And your second intercept is 3, 0, which is right there. Or if you were to graph this using y equals mx plus b, we would start at -9, rise 1, run 3, rise 1, hang on here, the fraction here is 3/1, not 1/3. So it's going to be rise 3, run 1, and if you graph the line, you can see it goes directly through the intercepts. So you can use intercepts, or you can use y equals mx plus b. The second thing we're going to talk about today is radicals. Radicals, also known as square roots. The very first thing I'd like you to do is I would like you to please, the first skill in working with radicals is to have the following perfect squares memorized. There's no way around this. You must have the perfect squares memorized through 16. So I want you to figure all of these out. Some of these you know. You may not use a calculator. Go ahead and use the space below if you don't know these by heart. Please do not cheat. Do not use a calculator. I'd like you to do the perfect squares. Please go. I'm going to give you a minute to try to do these. Okay, if you need more time to finish, please pause the video and then restart when you have done calculating the perfect squares all the way through 16. Ready? Again, these must be memorized. So 2 times 2 is 4, 3 times 3 is 9. This is going to be 16, 25, 36, 49, 64, 81, and 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. 16 times 16 is 256. Rehearse these because you're going to need these to help break down problems in the future. Now in radicals, there's 4 essential skills. 4 essential skills. One is simplifying radicals. The next one is adding, subtracting. The third skill is multiplying and dividing. And the last one is solving equations using radicals. Simplifying. You may have learned your own version of simplifying in the past. If you start recognizing what I'm doing and you have a different method and you get the same answer, by all means use it. You are not required to use my methods. I have two basic methods. I have a storyline for both. One I call going on a date. The other one, getting out of jail. That's jail, not J or jai. Add that L. You'll get used to my typos. Okay, going out of the date. First thing is you create a factor tree. And you simply factor it as far as you can. If it's an even number, I like to just use 2. It's even. So I'm going to go 2 in there, and I get 2 and 36. And you keep breaking it down. 2 and 18, 2 and 9, and then you have 3 and 3. Now, you are not looking at the branches. The branches are things you broke down. You're only looking at the leaves. Looking for the leaves, you're looking for couples. Couples are pairs. We see we have 2 couples here. We have a pair of 3s, and we have a pair of 2s. The whole going out on a date, when a couple goes out, the word couple technically is singular. There goes a cute couple. So when you bring out the couples, they are singular. We have a 3. We bring out the 2. And then we have one here. I'm going to box it that does not have a date. That 2 stays home and has pizza. Now to finish this off, we multiply what's on the outside, and the final answer is 6 root 2. That is the simplification of the square root of 72. That's called going out on a date. That's my version. Now a second version, getting out of jail. This takes a little bit more mental work. What you want to first do is consider the first maybe 4 or 5 perfect squares, of course, which is 4, 9, 16, 25, and 36. You want to ask yourself, can this number be broken up where one of them is perfect? One of these go in there perfectly even. If you look over here, we already see that 36. So I'm going to just break it down. 36 times 2. So I'm only dealing with 2 factors, one of them being perfect. Here's the storyline. If you're in jail, the radical is jail. If you are perfect, circle it, you get out of jail, but you must have a change of heart. If you're perfect, you get paroled, but you must have a change of heart. So the 36, when it comes out, becomes 6. 36 is perfect, gets paroled, becomes 6. Root 2, same answer. So in simplifying, you can prime, this is called prime factoring on the left. On the right, you have perfect square factoring. Use whatever rings a bell to you. What I like you to do is use either method, hit the pause button. I'd like you to break down 48 and simplify. Again, hit the pause button. Do this on your own first, then check. Okay, welcome back. I'm going to show you both methods, root 48 and root 48. I'm going to prime factor on the left. If it's even, I just like to use 2 all the way down. So I have 2 and 24, 2 and 12, 2 and 6, 2 and 3. Now I look for my couples. I have 2 sets of 2s. The couples, when they go out as a single couple. So I have a 2 here, times another 2. This 3 here, no date, stays home. You multiply these, you end up with 4 root 3. On the right-hand side, if I were to prime factor this, one of them being perfect, I know 16 times 3 goes into 48. So you have to be kind of good being able to recognize your perfect square factors. The storyline is I circled 16. 16 is perfect. It gets paroled, but it must have a change of heart. Same answer, 4 square root 3. Adding and subtracting. What's really nice about adding and subtracting radicals is that they follow the same rules as variables. You simply collect like terms. For example, in this example, I'm going to circle my x's, and I'm going to box my y's, and I'm going to collect. 3x plus 4x is 7x. I have 2y minus 6y, that's going to be minus 4y. And you're done. You can't do anything else more with that because you have x's and y's. Follow the same rules using radicals. We collect like terms. There's root 3 and root 3. Something with root 6 and root 6. 4 plus 2 is 6. So I have 6. Now those do not add. Just like here, this x and that x, they don't add. It's simply, it's not 7x squared, it's just 7x. So this is going to be 6 root 3. Then we have plus, that 2 plus 5 is 7 root 6. You don't mess with the radicals. The radicals function like variables there. That's for adding and subtracting radicals. Now when you multiply, stuff does kind of happen. When you multiply with variables, technically we're doing it twice. First we multiply the numbers, 3 times 4, which is 12, and then we multiply the variables, x times y, except that's as far as you can go here. When you're dealing with radicals, you're going to work with what I call outies and innies. When you multiply radicals, you do outies, innies, and simplify. Outies, innies, simplify. Let me give you an example. I'd like you to circle 2 and circle 4, please. Those are the outies. Draw an arrow, 2 to 4. Now we're going to multiply. 2 times 4 is 8. Square root. Now I'd like you to draw an arrow connecting the innies, which is the root 3 to root 6. 3 times 6 is 18. But wait, there's more. Be very careful here, because not only do you multiply outies and innies, but if you can, you must simplify, which we can here. This is 8 square root. There's a perfect person in there, and perfect people get paroled. Our perfect person in there is the 9 times 2. So 9 is perfect. It gets paroled to a 3. So on the outside, we're going to go 3 times 8, square root of 2. 3 times 8 is 24, square root of 2. Now you are done. So you multiply the outies, you multiply the innies, and then you simplify. That's for multiplying. Now to divide, you're going to go through these 3 steps. To divide, you're going to what I call clear the basement. You prime factor and simplify the radical and reduce, clear the basement. What I mean by clear the basement is clear the radical out of the denominator. So we have a root 50 here. The way you clear the basement is you're going to multiply the top and bottom by that same radical. So we're going to multiply root 50 times root 50. Now what does that become? Be very careful. That's going to become 5, and we have 6 times 50, and then down here we have 2, and then we have 50 times 50 down below underneath the radical sign. Now how does that clear the radical? Technically here the 50s have a date, so they can come out. So our first step is going to end up like this. We have 5, 6 times 50 over 2 times 50. Notice I'm not actually multiplying anything here. One of the tricks to be able to multiply without a calculator is not to multiply. Let me say that again. One of the tricks to multiply without a calculator is not to multiply. Instead, we're going to pull things apart. Okay, so we're done with step 1. We cleared the basement. Now we're going to prime factor and simplify. So I have 5, and now I'm going to break everything down as far as I can. That's going to be 2 times 3. Take it down to primes. 50, that's going to be 5 times 10, so that's 5. That's 5 times 10, which is 5 times 2. Let me just circle it in colors here. So we prime factored 6, that's 2 times 3. And we prime factored the 50, which is 25 times 2. So that's 5 times 5 times 2 over 2 times 50. Now we simplify. We have dates. Our first date is 2 5s, so I'm going to circle those and pull them out. I'm bringing out a 5. I also have a pair of 2s. I have 1, 2, and that's going to come out. Next line. So I have 2 times 5 times that original 5, square root 3 over 2 times 50. Now the last step is to reduce if you can. So to reduce here, the 2's cancel automatically. 5 goes into 50 10 times. 5 goes into 10 twice. Our final answer, after all that, is square root of 3 over positive 2. We're going to do more of this in class. If this looks really intimidating, it's fine. The more practice you get, the better you're going to get at this. Now, solving using radicals. Whenever you have a squared x, you're going to be using radicals in your solution at some point. So, first step, we want to isolate x. So in this case, we're going to add 4 to both sides. I end up with x squared equals 12. Now what I'd like you to do, I'd like you to draw a circle over here. I'd like you to write this equation, x squared equals 12. I'm going to wait for you to do that. Draw a circle and write in x squared equals 12. Okay, this is what I call a no-no circle. That means you don't do this. So what I'm about to show you is a very common mistake. And in a moment, you're going to show it and then cross it out. So you tell yourself, do not do this. No, no, no. Ready? This is the most common mistake. Students see the 2 and then they go, oh, there's a 2 there, so I divide by 2, end up with x equals 6. No. No, no. Because that 2 there is not the number 2, that 2 there just means I have 2 x's. So the opposite of squaring is not dividing, it's square rooting. The opposite of squaring is square rooting. So this is the proper inverse operation, not dividing by 2. So back to our original equation, we have x squared equals 12. So to undo the square, you do not divide by 2, you square root. So I end up with x equals the square root of 12. Now we have to prime factor this to see if there's any perfect people. 12, that's 6 times 2. So 2 times 3 is 6 times 2 again. We have a date. We're going to pull it out. So x in this case equals 2 square root of 3.